My name is Sean Walbridge, and I work on the Python team within geoprocessing. So I work on a lot of our desktop software and the core products, pieces, things like ArcPy. And this is Atma.
Hey, hello everyone. I work on the ArcGIS API for Python team. That's a new product, but I'm sure you all probably are familiar with that.
And hosted notebooks too, right?
And the hosted notebooks, that's a new thing. See, even I don't remember that. I got to keep telling myself.
So let me get this over to you and you can drive.
Thanks. So as you probably saw from the plenary, Python is huge in ArcGIS. It's a preferred scripting language. ArcGIS is a comprehensive analytics and compute platform. And Python is a preferred scripting language in that. And in this talk, we are going to look at the popularity of Python, a brief history of that. And we're going to look at the history of Python in ArcGIS. We'll get into a little bit more detail, talk about Python in different stacks, like in Python in the enterprise stack, Python in the desktop stack, in the runtime stack, and then give you a brief overview of the trajectory these different APIs are taking. So if you ask someone maybe a decade ago about Python, they would say it's probably a glue language or a scripting language that is used on server side, not really for desktop computing or something like that.
And scripting language, they say pejoratively, like it's, oh, it's just a scripting language.
It's just a scripting language. Yeah. It's not a real language. But then this graph from Stack Exchange, it puts Python to be the most popular language by sometime mid of 2019 or 2020, even more popular than JavaScript, and that too by a wide margin. In this meteoric rise of Python, one particular segment grew really big. That is the scientific computing packages. You saw a real large number of packages in this area, and a lot of these are pretty new, if you think about it. And then package managers like Conda made it really easy to install these packages on scientists' computers, and they solved the vexing dependency problem that's there in Python. You know, these advancements and the scripting nature of Python made it really easy for scientists to get their work done in their domain without having to learn a lot about programming. You know, that you can witness if you look at Conda alone has 1,000 packages, and the PyPy project manager, PyPy project package index has 150,000 packages. And you can see packages in all areas of the industry, from astronomy to finance to genomics to stock trading. On top of that, Python runs anywhere. It runs on Mac, runs on Windows, runs on the cloud, runs on embedded devices, runs on your smartphones. So what I mean by all of this is it's a fantastic time to be a Python developer. And if you're learning Python today, you're making a really good investment.
So one of the things that makes Python so amazing, and this is a clip from the film called The Matrix, where Neo wakes up to the real world and downloads into his brain the ability to learn Kung Fu. It's kind of like that, right? You suddenly just wake up one day and you say, I know Kung Fu. And the idea here is that by learning Python, the consistency of the interfaces that people use across different packages means that you can jump into something completely new that's outside of your core competencies and quickly get up to speed. A lot of the things that exist in other languages aren't there. There's an old joke about Perl that it's a write-only language. You write some code and you can't even read it 3 days later, never mind someone else. And this is a challenge across a lot of programming languages, that there's a lot of right ways to do something. And that inconsistency means that there's friction whenever you go to take some work and deploy it somewhere else or read someone else's code. And this is a really powerful thing in Python, right? If you talk to someone who's new, or maybe you're new at Python yourself, and you hear about, spaces and, meaningful white space, and, those things are, they can be troubling for someone at the very beginning, but that consistency really has a deep value to the ecosystem. And it means that the work that you do, other people can use much more simply. This also expands the base of who can use Python. There's a lot of programming languages where, ultimately most of the people that use them have the label or the hat Python developer or developer in that language. But Python's something that you don't have to just have that hat. You could be a domain scientist. You could be doing other things with most of your time and be pretty proficient still in Python. And that's a very powerful thing. There's only a handful of languages that have that same kind of flexibility. The other thing I want to show you today is just the breadth of Python in the Esri geospatial system. And there's a few ways we want to communicate that message. We ran a poll across all the people who are presenting here, who are using Python in some way in their talks. And there's lots of ways that you could slice this up, and there's some interesting details in those polls. But there's many, many sessions here this year about Python, and it's covering many different parts of our stack, but also the rest of the ecosystem. And this is something that, you know, the top two packages here are two that we produce, which makes sense. But there's also a lot of talks that will teach you more broadly about things going on in the base Python ecosystem, right? And this is a general trend that we're going through, that we find that more and more of these really powerful open source libraries complement what the ArcGIS platform brings to the table. And by using these two things together, you can do a lot of really great things. And that consistency that I mentioned earlier, it means that learning some of these new tools is not nearly as hard as it would have been in the past. There's a lot, even if you just come in through learning the ArcGIS API for Python or starting with ArcPy or whatever have you, you can pick up some of these other tools with much less work. And they cover many different domains too. They're not, if you look at this list, you see things like, you know, pandas, which is, you know, a NumPy kind of things from the SciPy stack good for numerical computing, for lots of kind of data analysis, but also things like requests, which is really great if you need to deal with sending and receiving web requests, or you're setting up a Flash server or doing something that is more on the web space. And even things like EXIF read, so you have like embedded metadata in images and you want to really dig into that. Like Atma was mentioning, there's really deep connection points in many different parts of the software ecosystem. And this is a story that continues to grow, and I think each Dev Summit has more and more Python talks, and sometimes now in surprising places. It used to be that the only Python talks were the ones that maybe the geoprocessing team hosted about the tools that we built and how to access them. And now there's Python showing up in every part of the platform. And that kind of segues into this slide that if you attended the plenary, you already saw, which is this idea of Python being everywhere and really being available to you across all the components that make up the platform. I think, you know, the breadth and depth of what Esri provides, it at times can be a little bit overwhelming. So it's good sometimes to take a step back and say, well, like, you know, I know this one thing. How can this be reinforced? How can I use this knowledge in other areas? And Python's actually a really great thing. You might hear about a new product, you might hear about something. Chances are that it has Python support in one way or another. And chances are you can take the knowledge you already have and apply it into that domain. And we won't have time today to get into all these details and to too much specifics, but this extends into many different product areas, many things that have things like Workflow Manager. These are tools that they have a surface, like they have a user interface and things that's not specifically bound to Python, but they also have an explicit Python binding that you can use to work with them. So that's always good whenever you're seeing anything new that we're doing if you know Python or are interested in Python, to ask, okay, is there an entry point into this through Python? And there's a good chance that there is. The other thing that I think is worth keeping in mind is the growth of Python from the Esri side. It's, you know, this kind of this hockey stick graph. This is just the number of packages that we include in our desktop product. So 10x and then on to Pro. Obviously very explosive growth with what we're including in the base system. We're adding new packages all the time that they solve new and harder problems. But we've been doing Python for a long time, and it's been around and it's evolved many times, right? We started out with bindings for many different languages. You could write Visual Basic, you could write Perl code, and it was just like Python was just another language. It was another one that you could use. But that grew into the ability to use any language. You could, then we added the ArcGIS scripting module. We kind of said, okay, Python is the one that people really want, and we're going to make that available. We started using NumPy. We added that ability to use that same module in server. And then ArcPy. ArcPy, I think, was the first real interface that made sense for people who were coming from a more general Python background. And we started integrating it more deeply, having the Python window, having these submodules. Background geoprocessing, the ability to have 64-bit Python environments, additional libraries. This continued growth, right? Raster function chains, get the full SciPy stack, ArcGIS API for Python, Conda integration, notebooks, environment support, and now some of the things that you've seen this year, including hosted notebooks and deep learning, right? This is, it's been really great. It's been really awesome to get to experience this. And
yeah, just this graph shows how much we are investing in Python.
Yeah.
Just within Esri and ArcGIS.
Yeah, that's right. And this is, if you were to take this 112, that's kind of like the lower bound of what's available to you today. And what I mean by that is that in like the hosted notebooks context, there's actually hundreds of additional packages that do even more advanced things that aren't represented in this graph.
Exactly, yeah. And one of the good things is there are so many other talks in Dev Summit that talk about how ArcGIS can work with other open source ecosystem. And you get the benefit of all of that in the hosted notebook environment, which is the ArcGIS notebook environment.
Yeah, and that notebook environment, it includes ArcPy. It's not just it's not just the things that are the ArcGIS API for Python. It's not explicitly only a service-based model. It has this dual model. It can do really anything that you can do most of the things you can do in both stacks. I won't say anything because that's always a slippery slope. So just a little bit of additional context about the desktop side of this. This is those pieces out of that earlier diagram, the connection point with Pro, with ArcPy. This is, I won't belabor this because you'll get to see other sessions about the desktop stack and Python, and there's obviously a lot of connection points. But that same graph that I showed you with the number of modules, the graph for the number of geoprocessing tools that you can directly use and access from Python, it's on a very similar trajectory. There's about 1,350 tools in Pro today. And so this is just one of those things that this virtuous cycle, right? You invest in Python, you start learning some basic patterns, and then suddenly all the things that are available to you in Pro and in server and all these different contexts, you can just use them wherever you are. And now hosted notebooks is a new execution context for those tools. So we continue to invest in heavily. I think I'm gonna, I can't back this up with statistics, but I'm pretty sure that if you were to ask across Esri, the most developers in Esri, the people that write the most code use Python, because we use it both for creating things like these geoprocessing tools for the more Pythonic interfaces you see. We also use it for all of our testing work and of all of our all the work that makes the software work the way it does. So it's a really big group for us, and it's an important language for us, independently of the tools that we then share with you. We mentioned Atma mentioned Conda. It's a big part of this too, in that it handles a very tricky problem that Python historically kind of shied away from, which is how do you deal with binaries? How do you deal with conflicting dependencies, right? I remember many years ago being really excited about some Python module, so I pip installed it into my ArcGIS desktop installation, and when I opened the application, it no longer functioned. And so I had to reinstall. That was not an uncommon story previously. So what happened there is NumPy got upgraded by pip, and then I could no longer use the desktop product. So we've done a lot of work to try to really insulate users from those issues, for making it so that you can't, the Python context that's coming with the application is independent, and you can use it and extend it. And there's still more to do there. We'll actually show something at the end of this deck that talks about that, but something that's coming up for that. So Jupyter Notebooks, we've mentioned a few times. This is something that now it's included in Pro out of the box. We now have this hosted notebook experience. And though this isn't really a desktop story, one thing I wanted to highlight there is that that means Python anywhere in that sense that Atma was saying, right? Mm-hmm. That means that you could have a notebook open on your iPad and be running Python. And that's really cool because platform restrictions and other things mean that you don't necessarily, you're not going to get a native binding in that language, you know, on that platform always. So it's really cool to see that happen. And I think we've kind of reinforced this last point that it kind of ties into this broader story, right? If you saw in the plenary, we gave a demo about GDAL and the integration there. We're always adding new packages. Another one, for example, that we just added in Pro 2.3 is H5Py, which gives you low-level access to HDF5.
Oh, great.
So yeah, we're always thinking about how can we augment this story and pull in things that we think a large base of our users can take advantage of. And while content environments are great and they're useful, it's often even nicer if we can pull something into the base, because then you know it will be available for you in any kind of deployment scenario. And the nature of this architecture means that we're using and reusing that in multiple different places, right? So if it shows up here, it will show up in the hosted notebooks environment at some point. They're not always exactly the same time, but that's the model. One thing I did want to mention is Python 2 versus Python 3. I'm sure there's some people who are here and wondering about it, and I get like panicky emails sometimes about this. And so, okay, let's start with the panic. Python 2 is dead from the python.org perspective at the end of this year. So, that should say 01. It says 0102. They're not giving you an extra day of support. I'm sorry. It's 0101 on 2020. But that's 9 months from now. So basically what's happening is the Python developers have decided that they're no longer going to support Python beyond that date. They're going to focus exclusively on Python 3 development. Now, Python 3 has been out for a long time. It's the support for packages is large now, and you know, it just in the last year and a half, it switched to the point where the vast majority of Python developers are doing all their work in Python 3. Now that might not be you. There might be reasons why you're still in Python 2, and we understand that. Our current plan is that we provide a support lifecycle for Python 2 that matches our product support lifecycle. But that would be limited to security updates. And if you're in a situation where you can upgrade, you really should upgrade. This ending of the python.org support for Python also means that all of the downstream packages, all the things that are cool to use with Python are also ending their support. So this means like matplotlib and Jupyter Notebooks, all of these different pieces of technology are saying, we want to make the same decision. We don't want to keep supporting Python 2. So it'll still be around. You can run things, and you know there'll be some work to make sure that it is a execution context that is secure and safe to use. But at the same time, it's going to get kind of ossified. It's not going to change much going forward. Python 3 we've been supporting for some time in Pro, and there's a context in server called the Pro Runtime, hosted notebooks, obviously, the ArcGIS API for Python's Python 3 only. We're doing all of our work today on Python 3. Now, if you have existing 2 code and you're like interested in getting it into Python 3 form, there's a tool here, and we'll share these slides with you that let you do this. You can just look up its name, Analyze Tools for Pro. That will tell you about differences both at the ArcPy level. There's not a lot of them, but there's a few of them. And it'll also recommend changes to go between Python 2 and Python 3. And those things that aren't in Pro are things like ArcPy.mp is different. It's now ArcPy.mapping. But even there where there's some equivalency differences, Pro is getting ahead. Like if you saw the sim demo, that's kind of this next generation ability to interact with the very rich data model of the map, which you can't do in a 10x based product. Mm-hmm. There's also modules like 6, which allow you to write a single code base, and that code base is going to be, it lets you use both Python 2 and Python 3. It will execute either place. So for example, ArcPy is written in this way. So we write a script, and it works in both Python 2 and Python 3. And it doesn't, in the cases where it doesn't need to differ, it won't differ between those architectures.
Oh, that's good to know.
Yeah.
Maybe we should poll the audience to find out how many of them are still using Python 2x in production. Quick show of hands. This is Python 2. Yes. Okay. How many of you are writing new code in Python 2? Like going back to your office and writing Python 2?
Yeah, so a lot still. Yeah, and there's lots of reasons for that, right? Well, I mean, this might be coupled to your organization's not on Pro yet. It might be, there's lots of reasons, and we understand that. You know, some people have asked us for Python 3 in 10x. I think that it sounds great, but the challenge there is that there's a lot of organizations who, like you, raised your hand, except there isn't even a U. They got a code base that they inherited, and they might have spent, you know, all the money that they had on it, and they don't have the means to just go and upgrade that. So this is our current plan, but we'd love to hear from you if you have needs or you're concerned about this not serving what you want to be doing in the future. Okay, and I'll turn it back over to Atma.
Thanks, Sean. So let's look at how Python is present and used in the enterprise stack. We just looked at how it was used in the desktop stack. Now we're going to look at how it is in the enterprise stack. There are two patterns in which you can think of enterprise stack. One is Python acting as a client. It's remote from the enterprise, or it drives and orchestrates the platform. The other pattern is Python is running within the servers that constitute the enterprise. So we'll look at both of these patterns. First, we'll look at the remote pattern. Yeah, so here, we can talk about the Python API, the ArcGIS API for Python. It does a lot of things for administration, content management. It can create users, groups, assign them licenses, roles, and all of that. You can establish distributed collaboration. You can clone content or users from one organization to another organization. A lot of such tasks in the automation area. You can do the same for content. You can also drive analysis through the geoanalytics server, the raster analysis server, standard spatial analysis, all of this running on the server side, but then you control it via the Python API. It communicates via HTTP, it authenticates via HTTP, it sends all of these commands and gets the data back and forth via HTTP. And if you look at the different modules in the Python API, you can see the various kinds of things you can still do being a remote client. You can manipulate features, you can do geocoding, run geoprocessing, or execute web tools. You can even do mapping. You can visualize web maps, author web maps, same for web scenes, etc. You can go even beyond. This is a beautiful picture that shows about the various kinds of apps that are in the wide ArcGIS platform. And the apps module within the Python API allows you to automate specific key workflows in these different apps. For example, with story maps, you can do things like you can customize a story map journal. In fact, that was the way the Alaska Department of Commerce did it that you saw in plenary yesterday. Yesterday? Yeah, yesterday. And then there is the workforce module where you can do key things like manage projects, assignments, dispatch. You can decide which worker picks up which assignment and so on. You can do the same thing for survey 1 to 3. You can look at the survey responses. So you can do analysis based off that. You can trigger a response, trigger a report and get it down and so on. And we are adding more and more modules to the Python API that can automate such workflows of different apps within the automation, within the ArcGIS platform. So far we have still talked about Python API and how we can manipulate or orchestrate the apps within the platform, still being a remote client. But I should also say in the previous slide here, ArcPy can also do this. ArcPy can also drive geoanalytics tasks. It can also drive raster analysis tasks, being a remote client. Now let's look at the other pattern where Python runs within the enterprise. So this is a base deployment. This is what you see in all of Esri's diagrams and talks. And then you can look at this server where you can have, in addition to the hosting server, you can have different types of servers. You can have an image server, image processing, raster analysis server. You can have a geoanalytics server, and a new type of server called notebook server that is releasing in March of this year. And this becomes your processing engines. And let's talk about how Python can run within these in the server context. When you look at the ArcGIS hosting server, the traditional server, you could use the same Python knowledge and Python scripts that you used, as Sean talked about in the desktop stack, and you can package them and publish as web tools and execute it on the server. ArcGIS Server has both an ArcMap runtime and a Pro runtime. So you can publish your scripts onto the server and execute it there. And when you look at the image server, you can author Python raster functions. These are all Python code, Python scripts, and you can publish it on the server, image server, and you can make it execute either dynamically or in a distributed fashion across the whole big data sets you have on the image server. A similar pattern for geoanalytics server. There is a new tool called Run Python Script tool where you can execute Python scripts on the geoanalytics server on your big data sets. And you know about the notebook server, which is kind of a sweet spot because it contains the Python API and it can still act as a remote client to your servers, but it runs in a server that is within the enterprise. And it can have ArcPy. ArcPy, the Linux version of the native ArcPy, and it has a suite of tools that is available, a subset of tools that is available in the desktop context within the hosted notebook server, and you can execute it on the server. So this gives a brief overview of how Python can run in an enterprise stack.
So that third tier in the stack that diagram we showed earlier is the runtime stack. The runtime stack is great because it gives you deep access to geoprocessing tools, right? So runtime is always growing. It's always growing what it can do just in its core. But this allows you to augment that with additional geoprocessing tools. And for those customers who use ArcGIS Runtime, they find this capability very valuable. The team who works on this, they take support requests to support additional tools or specific functionality that's needed. And they have a list of existing tools that's supported. They also have a demo lab that shows you the process of doing this. How do you get your tool packaged in a way that you can consume it in Runtime Local Server? They have a session later today to kind of go into some details on this if you're interested in it. And some of the folks who work on this project are at the native SDK's island. But we wanted to make sure you know about this, that if you use Runtime, people sometimes think of that as being pretty orthogonal to Python, but it's actually connected to Python and geoprocessing there as well. Okay, so I think the next section we wanted to talk about is what's coming next. What are we doing next? How are these things changing and evolving? And some of what we'd like to show you in this are things that you will see throughout other sessions here. And some are probably new to this slide. And we'll probably leave a good amount of time here to answer questions and get your feedback on what you would like to know more about or what you'd like to see and anything that we didn't cover fully. So we have a few big things going on. You saw the hosted notebooks. You saw what that experience looks like and how that could be useful to you. A part of this is that the notebooks are going to become a direct experience inside of Pro. And if you'd like to see a demo of this in an early state, I'll be giving a short demo in the Pro Road Ahead session. That's tomorrow afternoon, I think around 4 o'clock. And the idea here is that we want a rich environment for running local notebooks. If you already have notebooks open now, you want to use it to do all the things you can already do in the Python window, to control your map, to do different kinds of things that notebooks are really great for. So this is basically like another top tier item inside of your project file. So you have a map, you have adjacent to that a notebook, and you can have one or more notebooks open in your project file, and they just act like anything else. And if you've used Jupyter Notebooks on the desktop, one thing that's really great about this is that it doesn't require you to open the command line and like copy and paste some tokens. And you know, if you have a notebook open, then it's going to start a kernel on the back end and communicate to it. And if you have no notebooks open, then that kernel will stop and it will shut down, and it's a very kind of clean experience. And it can do everything that you can do now in the Python window. The other story is that this will be a rich client for accessing hosted notebooks. So if you have hosted notebooks in your portal organization, once they're available to you, you'd be able to open them and use them in Pro and be logged in with your portal credentials, and it'll just work in that context. The next piece of the story that is still in progress is the ability to move back and forth between those realms, right? So to publish a notebook that you produced locally into that hosted notebook context, and vice versa, download one and run it locally. Hosted notebooks is growing, and do you want to mention these, or oops?
Oh yeah, we're actively working on hosted notebooks. Key area that we are working on is bringing. I mentioned about the Linux ArcPy that is powering the ArcPy tool set within the hosted notebooks. So we are actively developing and looking at what new tools we could add to that and make sure we could bring as much tools available in the desktop stack within the native ArcPy stack. Another aspect the team is looking at is scheduling notebooks. A lot of users wanted this aspect where you can author some code, some logic, and get it run on a periodic basis. You can do it today. You can put it on any of your machines and make it a Windows task scheduler or some other cron job, or put it on a server and run it, Jenkins job, and so on. But we want to provide something that is out of the box. So you can author a notebook, say I want to run it every Monday or every Sunday at a downtime, go look at all my content, do X, Y, and Z. So that's something we are looking at, and that's going to be part of the scheduling notebooks. GeoAnalytics access through PySpark. The team that's building GeoAnalytics server is looking at how you can give you those bindings so you can run both Spark code via PySpark and also make use of the GeoAnalytics tools that the team has developed.
And the Insights team is also adding support for Python and R to its product offering. So we urge you to go stop by and talk to that team and find out more about that. And yeah, so we also hear you. You know, there's gaps between how things are done the quote-unquote ArcPy way and the quote-unquote ArcGIS API for Python way. Some of those are a function of time, right? Like I showed in that graph before, ArcPy has been around for a long time, and there's newer approaches to doing things that are available in the Python API. But some of these are things that we can address. We can make them interoperate better. Internally, ArcGIS API for Python is using ArcPy in many contexts for many of the things it does, so it's not like we are, but we know that sometimes those interfaces have mismatches, which are frustrating for people when they hit them, so we're working on that. And the last thing we wanted to mention and just show you briefly is the ability to use ArcPy in external Conda environments where you have Pro. So what this looks like is you still need to have a Pro installation for this to function. It needs to talk to the rest of the ArcGIS software stack. But if you're using something like Anaconda Navigator, or you're using PyCharm or some other context where you can list and manage packages, you can now install ArcPy into that external environment. So this is great for those of you who are heavy users of environments and want to be explicit in everything that you're managing. This won't work right now, but after this deck, I'll make this command work. It's a tech preview at this point. We're just still trying things out. We're going to be shipping this experience in the upcoming release of Pro, but it's pretty cool. It also means that we will have a pattern for supporting upgrading environments across Pro releases. So the idea there is that today, if you create an environment and then you create 5 environments, you upgrade Pro, it's going to contain different binaries that aren't compatible with the environments you made will have the old version still. So this gives us a story for upgrading those, and useful in these external contexts. So yeah, I think that's everything we had. We definitely have time for questions. I know it's kind of weird to have a session where there's no demos, but we really wanted to have something that gave you the whole picture and connected things together, because I feel that's always a gap sometimes, that you go into a very specific detailed session and you don't get a picture of how these things fit together. Mm-hmm. All right, any questions? Are you talking about like what's shown in this slide? Yeah. So this is a Pro-specific context, like it says in the top there. So what this is going to do is, if you have Pro installed already, it's going to hook into that context. It's going to locate your Pro installation and use that. It's going to do the licensing through Pro. It's going to work that way. If you're talking Linux, and so right now the new answer for that is hosted notebooks, right? We also have the native Linux ArcPy. If you have a server instance, there you can make as many Conda environments as you want. You have to just have a server license, which is not everyone. But you can also use the same pattern on server to make as many environments as you want and have ArcPy available in all of them. Yeah, no problem. I'm sorry for the people over here. This like giant piece of wood was not helping us.
Any other questions?
Any other questions?
Well, there's one point I forgot to make when I was talking about ArcGIS API for Python. How many of you here know about PortalPy and ArcRest packages? PortalPy? ArcRest.
ArcRest.
Fantastic.
Yeah.
So Python API sits on top of those two packages. We use ArcRest to the admin module within the GIS module of the Python API makes use of ArcRest to do a lot of administrative activities. And same way, the PortalPy is actually forming the bedrock of the Python API that makes the connection between the different versions of portals and the communication and all of that.
Cool. All right. Well, there's no other questions. Then I guess we'll get out of here a little early. Thanks so much for coming. We really appreciate your time.
Yeah. Thank you.